Hi, everybody. I'm Elliot from the Lindy Group in Emeryville, California. This is a beautiful view from just across the bay in San Francisco, looking at the Bay Bridge. That was my commute for a long time. And we are always looking for excellent Mac talent. So if you want to live in the Bay Area, among all those exciting companies, please contact me because we're hiring like crazy. We need people. So my talk today is how not to do bad things with Autopkg. And like many of you, I'm sure most of you are using Autopkg in some big or small ways to make your life easier. And we often hear about how great the tool is, and spoiler alert, it is fantastic. However, we don't always hear about how to avoid common pitfalls and use Autopkg safely. So that's kind of the subject that I'd like to break into today with how not to do bad things. And of course, that's kind of a cheeky title because in order to show you how not to do bad things, I first have to show you how to do bad things. But that's kind of fun too, so we'll have some fun with it. But of course, it goes without saying that you should only use your newfound powers for good and never for evil. So let's get rid of that for a minute. And let me talk a little bit about what I call the software supply chain. I don't know if anybody else calls it that. You can call it what you want. But it's basically how the software ends up going from the developer to your endpoint computers in your organization through a series of things like the source of the download, through the network that you're connected to. And if you're using Autopkg, you're using processors and recipes that are coming through GitHub, through your network, and then through your distribution system like Monkey or Casper, finally to your company's computers. So all of these points are vulnerable in some way, and I'm going to show you a little bit about each one of them. And there's also a way to mitigate each one of those vulnerabilities, and I will, at the end, show you all that as well. So that's the overview. We're going to start with your Autopkg Mac. It's the easiest one to exploit, I think. And the first thing I thought of, actually, when I was coming up with this presentation was Path Deleter. Path Deleter is a fun processor. It does what it says on the box. It deletes things. You can pass it an array of strings, and it will delete the paths associated with each of those strings. So it's pretty self-explanatory. And it's really useful, too, if you're cleaning up a recipe cache folder while you're making a package. You know, if there's any junk left over that you want to clean up, you can do that with Path Deleter. So for example, here's my Apache Directory Studio package recipe that cleans up some unnecessary junk after it creates the package. But you can, at the very least, make Path Deleter counterproductive. For example, here's a recipe that deletes the package that it just created. So it's kind of digging a hole and then filling it back in again. But if you want to have a little bit more fun with it, you can actually go outside the recipe cache folder and delete like your recipe overrides, for example. It doesn't care. If you have access to it, it's going to delete it. So it does what it says. So rather, it does what you ask it to, if you ask it the right way. And if you do that, this is what it looks like. Boom. So there's another one that I wrote that deletes my photos. And I actually used an input variable to figure out what the current user logged in is. So it actually doesn't delete just my photos. It deletes anybody's photos. It's not picky. And that looks like this. Yeah. We can't go too far with that because there are actually extended attributes and other things that protect us, protect certain files and folders from being deleted unless you do things above and beyond. That's why you see like required by OS X when you try to delete your desktop or documents folder, as I often do. But there is a folder that you do usually have access to read and write to if you're running especially monkey recipes, which is your monkey repo. If you put %monkey repo in Path Deleter, it will actually do that. There it goes. So hope that was backed up or versioned or something. And now we have just affected our software distribution system. So you can see this is going to turn red, right? But let's be real. if you see path deleter in an Autopkg recipe, a red flag is going to go off, and you're going to think, oh, that's probably deleting something. But if you see copier, you may not think that. How can making a copy cause any damage whatsoever? But if you look at the input variables, you actually see that there is an overwrite input variable, and if that's set to something other than false, I think it's, yeah, if it's just set, it will overwrite the directory that it's copying to. So that has the same effect as deleting something, as overwriting it in place. So here is the same example. Our monkey repo is being overwritten now instead of being straight up deleted. And it's going to download a new version of Cake Brew and write it to the monkey repo. Not the right way, yeah. In fact, there's actually a bunch of processors that will overwrite things if you give it the chance to and if you give it the right input. Some of the processors can overwrite files and some can overwrite folders. But you can accomplish any of the path deleter stuff in a more subtle way by using copier or any of these other processors with the overwrite flag. Some of them actually don't even have an overwrite flag. They just do it. So it's a little bit more subtle. You got to watch out for that. But we don't actually need to limit ourselves to core processors. It's actually really easy to write our own processors and do whatever we want. So this is a processor that deletes your applications folder. And first it does a sudo chmod -N, which removes all of the extended attributes from the applications folder, all the protections that would otherwise prevent you from doing this. And then, of course, rm-rf. And that looks like this. So as you can see, it says unicorns and rainbows, nothing to worry about here. Please enter your password. If any Autopkg run asks you for a password, that's a red flag. You should watch out for that. But I say, OK, rainbows and unicorns, right? So I go ahead and put my password in. And now this happens. This is the most pleasing visual of the presentation. I love this. Yep. So you can also do other things like hijack DNS. Now, here's a processor that actually sets the DNS to something other than what's provided by DHCP or hard-coded in. And so normally, if you run that without sudo, it brings up an Apple standard authorization prompt, like, we're about to make network changes. Please put in your password. If you run it with sudo, that doesn't even come up, but you should never do that. Here's what that looks like. Notice the DNS server is now some bogus IP address, series of IP addresses. And obviously, you know what a DNS hijack is, probably. If you are able to control the DNS that a computer is using, your Autopkg computer or any client computer, you can control what IP address they get when they ask for a domain name. So instead of going to mozilla.org and getting the latest Firefox, we might be going to some other IP address that's not related to mozilla.org and downloading the latest version of MacKeeper. Never know. There's a couple other processors that I kind of refused to write because I didn't want to release them into the world. One was the JSS credential sniffer. JSS credentials, if you have JSS recipes configured properly, the com.github.autopkg plist contains your API username and password. So it doesn't take much for a processor to curl that up and have like a web app catch it or something. So don't do that. And SSH key sniffer as well. You can take the contents of your .ssh folder, including all your private keys, and curl those up to a server somewhere. So that's kind of scary. Next bad thing is what I call naming curiosities. And by this, I'm referring to the way that Autopkg has a search directory path. It uses identifiers and names and things to go down the search directories listed here in order, looking for the thing that you're asking to run. And we have an order that is specified in this plist, the com.github.autopkg.plist. If you can somehow get a recipe repo ahead of the legitimate recipe repo, you can hijack all the recipes in the legitimate repo. So for example, if I create a new Firefox recipe and put that in a folder that's earlier in the search path, with some small modifications, like turning off code signature verification and changing the description, we can actually take the official monkey recipe for Firefox identifier and hijack it so that it runs some other recipe. We can also actually run that recipe and see disable code signature verification is turned on, which is not the case for the standard recipe. That applies also in any recipe in the chain. So if you hijack a download recipe by putting something earlier in the search path, you can actually hijack all of the recipes after it, kind of, by design. So I call that an evil step-parent recipe, as opposed to a parent recipe. I thought that would get some laughs. Oh. All right. Noted. So the same thing applies to processors as well. If you have a processor that's in the same folder as a recipe that calls it, you can swap in a processor that's not the legitimate one. So for example, here I have a Mozilla URL provider inside my newly hijacked folder with the recipe, Firefox recipe in it. When the Firefox recipe calls the Mozilla URL provider, it's not going to get the one from the official Autopkg organization. It's going to get the one that's stored in this folder here. So that's a feasible option for obfuscating custom processors that are doing bad things. So on a seemingly unrelated note, did you know that capital letters sort before lowercase letters in Bash and Python? I learned that in the past few months. It's very interesting, I think. Next, surprise variables. So perhaps you already know that there's a way to use -k to kind of inject variables at runtime when you run Autopkg. Here, I have given an example of actually running the AD passmon download recipe, but I've injected so many different variables into it that it actually ends up with the monkey admin zip. Totally unrelated app. So if somebody who has access to the Autopkg script runner, for example, wants to put in some extra variables, they can kind of change whatever they want. And with that, we've now affected our endpoints. It's getting an actually different app than they were expecting to. So that's fun. So next one is called surreptitious scripts. So scripts can be bundled inside of recipes, for monkey recipes, for example. For package recipes, there's usually a scripts folder. It doesn't need to be called scripts, by the way. It can be called unicorn. But usually package recipes contain a reference to that if there's a pre-install or a post-install script. So take a look at this monkey recipe. I call this one goingdark.monkey. And as you can see, it's got a script built in there. It's a post-install script. And if you run that and it imports into monkey, all your clients stop checking in because this script uninstalls the monkey tools. So you'll be walking desk to desk shortly after you run this one. And suddenly your Macs are on the loose. So that's the thought of reconfiguring the monkey tools on a few hundred employee Macs is enough to make me sweat bullets. I don't know if anybody else wants to walk around that much, but that's not fun. Same thing for JSS recipes. We can't let our Casper friends have too much safety, right? So here's a JSS recipe that does a similar thing. There's actually a goingdark.sh script referenced here. And this is the script. It turns off SSH, looks for Casper check and unloads it, and then uninstalls the Casper framework. So those Macs are no longer checking in. Scope that to everybody, and you've got a problem. Here's one that's even more terrifying, if that's even possible. This creates an account that's enabled for FileVault, and only enables that account for FileVault, and then immediately restarts and leaves you with this. And yeah, you probably can't read it at the bottom, but it says, if you want your files back, please send 100 Bitcoins to so-and-so. This is ransomware, so don't do that. I think I've made my point. So with the right Python code, you can basically do anything on your Autopkg Mac, on your client Macs, anything in between. But all of the examples I've given so far have relied on kind of stupidity. Like you put something bad in a recipe or in a processor, and you're thinking, but wait, I'm not going to do that. I'm not going to write a ransomware recipe and deploy it. That would be stupid. Yes, you're right. You're a good person, and you're not going to do those things. But let's assume for the moment that you're never going to do those things. What about all the recipe authors that you subscribe to on GitHub? Those changes that you're applying to your recipes are not coming from you, right? So what's to keep somebody else from doing something stupid? And let's say even if we do trust everybody in the Autopkg organization, which I tend to, because I believe that humans are more good than bad, but what's to say that down the road somebody wouldn't get a recipe repo who's not so trustworthy, you know? And let's be honest, the bar for getting a repo in the Autopkg organization is not that high. You just make a bunch of recipes, you put it in a new repo, and you ask to be forked, and that's pretty much it. Also, even if everybody involved in the Autopkg organization is trustworthy, and even if they remain that way forever, what's to stop their computers or their email accounts or their GitHub accounts from being hacked? You know, do they all use two-factor authentication? Do they all have good passwords? You know, is their email password da or something like that? You don't know. Sorry. So with that, you know, if GitHub comes crashing down, then we've suddenly taken that whole row at the bottom there, and the processors and recipes and GitHub itself is potentially compromised. So trust without verification. Was it Reagan that said trust but verify, I think? But it's good advice. If you don't look at the changes that you're applying when you run repo updates, then this is the way that those other stupid things get to sneak in. If you're not paying attention and checking all the changes, then you know, who knows what's going to happen under your nose. So you want to make sure to check that. And if you're using a GUI tool, it's especially important because it's easy to be oblivious. I know I'm the one that put this checkbox in there, right? I know I'm guilty, but I recommend not checking it. And the reason is because if you administer Autopkg to your organization, you owe it to yourself to know all the changes that are happening in all the recipes and the processors that you're running. And yeah, so this all sounds kind of far-fetched, right? Like my organization's not going to get targeted, and GitHub's not going to get hacked, and everyone else is super trustworthy. Like, what's the worst that could happen? Well, if we assume that we're safe from malicious intent, and we assume that people aren't stupid, and that these things and we're not being targeted, then nothing bad can happen, right? Wrong. I've got 8 more to go. Just getting started. Next is plain boring typos. Everybody makes typos. And most of the time, Autopkg will refuse to run recipes that have a typo in it because it's usually like a syntax typo. Like this one, for example. There's no closing alligator bracket after string. And so Autopkg will just fail on this one, and then you'll be forced to go in and look at the recipe and fix it and all that. But it's not hard to imagine that a typo could cause more damage. Like if you improperly escape a space in an RM command, that could potentially remove 2 files or more instead of the one that you wanted to remove. So next, technical confusion. This is pretty simple, right? Autopkg can be kind of a complex system, and the people that set up Autopkg may not be the same people who administer it on a daily basis. So for example, considering the following situation, if you normally override monkey recipes and send new software to a testing catalog, as many people do, you just hired a new guy, and he added a new recipe for a new thing called monodraw. And by default, that recipe sends monodraw to the development catalog. Cool. Everybody with me so far? Now, when he runs that recipe, suddenly he gets a development catalog that didn't exist there before. Cool. So far, so good. And by the way, your company has developers, and there's a manifest called developers. And the new guy sees, oh, there's a developers manifest, but it doesn't have access to the development catalog. Well, surely that's a mistake, right? It's not a mistake, and don't call me Shirley. The new guy adds it, And the developers are now getting untested, like unfiltered releases of MonoDraw. And if they depend on MonoDraw for their daily workflow and some bug comes out that would have been caught by testing and wasn't caught because it's going directly to their computers now, then you've just pissed off some people. So the difference between catalogs and manifests and all that stuff is not something that the new guy knew about, and so he shot the organization in the foot. Similarly, there are 2 Firefox JSS recipes, and people that are new to JSS recipes may not realize the difference between the two. One of them has a pre-install script that actually removes Firefox before reinstalling it. And in certain situations, the removal script might run, but the reinstallation never happens. Based on some inventory thing with the JSS. I've seen it happen before, like Firefox just disappears, and then suddenly they're not in the Smart group anymore, and they don't get Firefox reinstalled. So that could potentially cause problems. And anything related to Autopkg and Casper has at least like 3 or 4 levels of depth and grok until you really get into it and start changing things. So it's potentially technically confusing. Did you already install and configure JSS importer? Where are you getting the JSS recipes from? How do they behave? The JSS recipes, like official repo, the recipes all try to behave in the exact same way. But there are JSS recipes outside of that repo that don't behave that way. So that's all really complex, really fast for some people. Next, find and replace FLUBS. This is something that I've been guilty of. I had a recipe for cake brew, have a recipe for cake brew, but it should have been cake brew with a lowercase b, because that was the technical product name. So I thought I was being clever, and I did a find and replace on cake brew. I didn't do the identifier at the time because I knew that would mess everybody up. But what I forgot was the name in Monkey was also being used in the manifest, and the manifests are case sensitive. So suddenly I had 2 different versions of cake brew in my Monkey repo. One of them was capital B and one was lowercase b. But the only one in the manifest was the one with the capital B. And I thought mistakenly that cake brew had stopped updating. I embarrassed myself a little bit on Twitter. Don't do that. Next, loose licensing. Flip for Mac used to have recipes that actually included, I'm not sure if this was accidental or just because of the way that Flip for Mac created their package files, but they would be fully licensed if you deployed them with Autopkg, even if you didn't pay for it. It's awesome.
If you ran the installer at all.
Yeah, if you ran the installer, it would be fully licensed. So those were removed eventually, but that was potentially a problem if you wanted to be on the up and up with Flip for Mac and install it with Autopkg. There was a potential problem there. And another example would be something like a Mac App Store app like Final Cut Pro. Using App Store app recipes, recipe overrides, you can distribute Mac App Store apps far and wide, even if you don't own the licenses for all of those numbers of computers that are installing it. So it's just something that the administrator has to take responsibility for in catching, making sure that it's not in manifests that are going to deploy it farther than what you own. Another scenario, software regression. So let's say, hypothetically, that a major app release removes features that your video editors depend on, hypothetically. Or let's say that a web browser update breaks an important internal web app and it just no longer works because the app developers don't use real security. If you deploy these updates to these apps without due diligence, you're going to get a call from your video editors or your legal team or whoever that depends on these apps and can no longer use it. Sideloading and hijacking has actually been in the news recently because there was it last year already or earlier this year? There was a Sparkle framework vulnerability. The 10-second version is that if you were using an unsecure Sparkle feed, you were susceptible, and an older version of Sparkle, and you were susceptible to a man-in-the-middle attack that could do bad things. That's obviously not an Autopkg issue, but you could imagine how man-in-the-middle attacks in general could be used on your network to kind of sideload something into your Autopkg repos that you weren't expecting. So that, with that, your network would potentially be at risk there. Similarly, what if a major developer makes a deal with another company to bundle adware in its software? The Autopkg recipe is probably going to be updated really quickly to accommodate that. Thank you, by the way, Tim. But in the meantime, what if your what if Autopkg runs in the 2 hours between when this adware was introduced and when the recipe was updated to extract it? You could potentially end up with the Yahoo toolbar on your company Mac or something like that. And that means the developer sometimes isn't even trusted. And what if the developer gets hacked? You know, what if somebody gets access to the developer's website and puts on a bogus version of their software? Or what if a site that Autopkg recipes use to download software starts injecting their own adware with or without the developer's permission? That's not hypothetical. This actually happened twice. So that means that the download source isn't always trustworthy either. So the last bastion has fallen, and love the flames. Got 2 more to go. So administrative fatigue is, have you seen these emails? You know, new version available for testing, Chrome, VLC, Office, you know, home, whatever. Two versions of VLC available for testing. How do you get 2 versions in the same repo without, you know, I don't understand. Well, the way you do that, by the way, is to run 2 recipes that both do VLC, but they put them in different places. But anyway, it's beyond the scope. But if you get a lot of these notifications, you're going to start filtering them, either literally out of your inbox or like figuratively in your head. You're going to start ignoring them. And the more alerts you ignore, the less the real alerts are going to get your attention. So it's like the boy who cried wolf. You know, you get enough of these emails and they just don't mean anything. And finally, over-automation. This is something I'm definitely guilty of sometimes. Company A just wants Flash deployed, newest version all the time to all the Macs, no questions asked. And so I wrote a recipe override. This is literally the recipe override that I wrote that automatically deploys Flash to all the computers through the JSS. And sure, that's nice. It's great for catching those security vulnerabilities really quickly. But if a bad version of Flash ever lands, it's going to be pretty painful to go and, you know, and roll back from that. Now, ideally, you just uninstall it, but this was for a company who needed it, so we did it. So that's 15 things that I went through real quick that you could potentially do and you need to avoid with Autopkg. And that's it. No, I'm just kidding. So there is hope. I'm going to show you how to avoid all those things now. And to do that, we're going to put the not back in the title. And I'm going to move pretty quickly through these suggestions, but the whole list is available online on GitHub, and of course, you'll be able to watch this again later if you want. So I'll talk quickly. Don't feel the need to take notes or anything. First, don't run Autopkg as root. Autopkg itself is pretty emphatic about this. If you try to run Autopkg with sudo, or I think even as like by logging in as a root user, you will see this warning, warning, warning. So it's kind of hard to ignore. Most of the recipes I showed you, especially the earlier ones, require administrative privileges in order to do anything bad. So I would recommend taking the advice that's presented here and running Autopkg as an unprivileged user. That means no admin privileges either. Create a user called Autopkg with no admin privileges and have it just do one thing. That's a good way to kind of make a little fence around the potential damage that could be done. And you may think, well, permission denied, you know? I've seen this before, and if I escalate my permissions, then suddenly this error goes away. That may be true for things like tail, but it's not true for Autopkg. You're just going to cause yourself more trouble. So if you see permission denied, or if there's some kind of a, permissions or privileges error that you see, there's usually an underlying problem, and that deserves troubleshooting rather than just trying to escalate above it. If you encounter permissions errors and you're using a beautiful graphical user interface like this one, you may see something like this. It's a little bit more obfuscated. You wouldn't you wouldn't see at first glance that this is a permissions error. I guess it says failed to write plist data, but you don't know why it failed. So the first step is to go back to the terminal, run the recipe there, and see what more verbose output you get from that, because I'm guessing it'll be more useful. My next suggestion is just as important, I think, and that is to read and write recipes. The ability to read recipes is a must if you're administering Autopkg, and they're plists, right? So they're something that most of us should be familiar with already if we manage profiles, or if we go all the way back to Workgroup Manager and MCX. Plists have been a part of Mac admin culture and know-how for a long time. So I would recommend looking through all the recipes that you can, certainly all the recipes that you run. Start picking up on the patterns and the similarities and the differences between them. I'm actually, next week at PSU, I'm going to be giving a whole talk about how you can use Recipe Robot to help you do that. So tune in after that if you're interested in that. But the Autopkg wiki is especially useful in this regard too, because if there's anything in here that's unclear, you can just look up the key that's associated with it in the wiki. Or in various processors are explained as well. The arguments for the processors and how they interact with each other is pretty laid out, pretty bare there. Writing recipes takes a little bit more work. If you can write like this with 5 keyboards at the same time, kudos to you. I can't do that quite yet. I was actually a latecomer to the Autopkg scene, and I went through this the hard way. I learned how to write recipes because I had to, and so I came up with a little mini list of things of tricks that I employed to help me do that. And the first I would say is to start small. Start with overrides, because overrides are super useful. There's probably already a recipe for the app that you need, and all you need to do is override the category or the catalog or something like that. So start small. Don't be afraid to copy. If you see recipes that are similar, for a similar app that you want to deploy, if it's a signed zip, for example, or if it's an unsigned DMG, you can copy a series of recipes that already do what you want and just change the name, tweak it until it works, and there's your first recipe. And of course, use Recipe Robot. I'm going to tell you right after this session a little bit about Recipe Robot, just a quick 10-minute introduction. But the short version of the story is that you can use Recipe Robot to create a recipe and then diff it with the recipe that you wrote and see where the changes are that you might have missed, or give you some ideas for how to do things. And of course, you can always run diffs against existing recipes as well. You can spot, for example, the one on the right here has code signature verification, and the one on the left doesn't. So you can get ideas that way as well. And of course, use a good text editor with syntax highlighting. Text Wrangler, Sublime, Atom, TextMate, those are all great text editors. Word is not, Pages is not. I've tried. And then use utilities like plutil to tidy up after yourself. After you write a recipe, run it through here and see if it lints properly. The lint command will check to see if all the syntax is good. And I would do that even before doing an Autopkg run, because it'll catch things that even Autopkg might not. But it's been really handy for me. I also use plutil convert to actually convert to standard XML1 format, even though it does some things I don't like, but it makes it really easy to compare my recipes that I write with automatically generated recipes down the line. And I can see some of the things that I missed, or steal some of the good ideas that Recipe Robot comes up with. And then finally, when you're writing recipes, use trusted sources for downloads, of course. The developer's site is always the #1 most trusted place. It depends on the developer too, and how secure they are. But usually you want the software directly from the horse's mouth, as they say. If the project is hosted on GitHub or Bitbucket, I would say those are equally good. I would generally avoid SourceForge lately. It's been kind of questionable reputation. And Mac Update is nearly always just a middleman. You can get the software from wherever Mac Update is pointing to, rather than from Mac Update itself. And Google Code, for the purposes of Autopkg, isn't that useful anymore, since it's no longer in use, deprecated. You're not going to get any updates from it. And of course, remember that you're not alone. When you're writing recipes, you can reach out on the Mac admin Slack, and there's always somebody there. Not always. During business hours, there's somebody there to help you out. Next big tip, isolate your Autopkg Mac. This is probably the single most important way to limit the damage when you're using Autopkg that could potentially happen. Having a strong wall between the various parts of the systems is going to protect you from potentially bad things happening. I tend to run Autopkg in VMs using either VMware Fusion or Parallels Desktop, or on a dedicated Mac that is supposed to only be running Autopkg. Don't run Autopkg on the same Mac that you run, for example, your Monkey server or your Casper distribution point on. Chances are nothing's going to happen. You'll probably be fine, but just don't do it because it's just one more thing that could potentially fail, and you would have to untangle that mess if it ever stepped on something that it shouldn't have. Next, verify code signatures. Always. Code signatures are the things that Apple embeds in apps to basically prove their authenticity. And that's what tells you that you're getting the app that you're actually wanting and not some imposter app, like that one. When a code signature error happens, I always recommend running the resulting app through something like RB App Checker Lite, which is that app there. And that'll tell you all the details of why it failed code signature verification. Sometimes it's actually a developer problem, in which case you can complain very politely to the developer and kind of poke them and see if they can fix that in the next release. This is actually a perfect Twitter thread that I found. I couldn't believe I found something that illustrated that point so perfectly. But somebody reached out to the Screen Hero developer and said code signature verification or code signing isn't working. And the developer got back and said, yeah, thanks, I'm working on it. It's perfect. That happens. Pay attention to the changes. This is how. Instead of doing repo update all, or instead of checking this box, actually open up the terminal and type cd, navigate to the repo that you're trying to update, do a git fetch. Now, I should say, I'm actually a Git novice, so if any of you know a better way to do this, please speak up. I just learned this recently, so this is the best way that I've found to do it, but I'm not saying this is definitive by any means. I do a git fetch to pull in the latest changes but not apply them yet. I do a diff against the origin master branch, and that will, depending on whether you have the color coding turned on, I think it's ANSI colors in your terminal, it will show you the green and the red here about what's been removed or modified or changed. If you want, you can even use a diff tool. I use Kaleidoscope, for example. It gives me a little bit more graphic user interface and lets me scroll a little bit more easily than the terminal does. And only after you review all the changes and they all look good to you, then you can do repo update, Autopkg repo update dot, and that will repo update the current directory that you're currently in. So, and then you repeat that for the remaining recipes that need it. How do you know, repositories that need it. How do you know which repositories need it? Well, you can open up Autopkg if you use that, and a little yellow indicator on the right side there will indicate which repositories need update compared to what's on GitHub. And if you right-click on any of those repositories, you can get access to other options, like you can go directly to the GitHub commits page. You can copy the path of the repo to the clipboard so that you can go cd to it in the terminal. So that's how I've been doing it. Anybody have a better way? Yes. All right. I love when I guess right. Next, use overrides liberally. I would argue that there's very few cases in which you should actually run a raw Monkey or Casper or JSS recipe to a production server. You should nearly always override those. If for no other reason than you just need to change the category or the description or something like that. It's just good practice to override the recipes that you're going to run. And you may actually find other reasons to do an override as well. For example, if you have an app, like a paid app, that you want to lock down a particular version of that you've paid for, like 1Password, for example, if you've paid for version 5, but you don't yet have a site license for version 6, you can lock the major version of that in your override to 5, and it will not download a newer version of 6. And of course, you can deploy App Store apps with overrides, only when backed by licenses you actually own, of course. I think managed distribution is probably the way of the future for that, but if you still want to use auto-package recipes to deploy App Store apps, you can still do that. Mass edit with caution. So if you make a lot of changes to your recipes, don't change things willy-nilly. You want to use a scalpel, not a shotgun. So I would say don't change identifiers after production. I would be guilty of ignoring that on my own. I have a recipe that I just changed identifiers for, and I kind of regret it. I probably shouldn't have, but it's too late. Cat's out of the box. So don't make my mistake. Don't change identifiers unless you really have to. It's messy. If you make bulk changes too, make sure to test those changes before you commit. So here's a one-liner that I sometimes run that just runs all the recipes in the current, or in the specified folder, and make sure that they all work. Obviously, you would do this in isolation on a dedicated Mac or on a VM. But this way, you can catch any errors before you put them on GitHub and have other people complain to you about those errors. And of course, consider the context. If you wanted to replace curl downloader with URL downloader, for example, you wouldn't just simply replace curl with URL in all of your recipes, because there may be some code signature thing that has that string in it that you would be totally breaking if you did that. So you'd want to expand the context and search for something like string curl downloader /string to make it more specific and reduce the false positives. And obviously, you'd want to review all the stuff you did, the diff of what you did versus the master branch, to make sure that the changes you made are still good and you're signing off on those. Inspect packages before deploying. This is a tool that a lot of people talk about continuously, which is great. It's a great tool. Suspicious package shows you this. It lets you see inside of a package before you deploy it, before you even test it if you want. And you can look for things like install scripts and look inside those scripts and see what they do. And that will help you catch a lot of potentially nefarious stuff before it even gets to the development phase, which is great. Don't deploy to production. Again, guilty, but most of the time, you should not have a workflow that looks like this. New software comes out, immediately goes to your Macs. Rarely is that ever really necessary. Most of the time, there's going to be steps between, intermediate steps. You should test the software locally, make sure that it runs, make sure it's not a lemon. Stage it to a few testers, people that are going to give you feedback that you can use to decide whether you want to deploy. And that's the better way to do it. So imagine yourself like the quality assurance manager at like a restaurant. What do you have to do to make sure that your patrons don't get food poisoning and call you and sue you and all that? Your company's employees are those patrons. You want to make sure that their Macs don't get package poisoning, I guess. The metaphor is running out. And of course, documentation. You want to write everything down. Read through it yourself and make at least one pass at making it better, especially if you're actively doing a process. Redocument that process. Go back and read the documentation while you're doing it and make sure that it's up to date. Have somebody else read it. Have somebody else make your peanut butter and jelly sandwich and see how messy they get. It's a really great way to point out the flaws in your documentation. If the person who's writing it is no longer the person who's reading it, then it's a whole other way of seeing it, and it can potentially open up some good improvements. Shay Craig introduced me to a great idea, which is called a documentation jam session. Just like 1 hour a week, just get together with your team, go through documentation, make it better, add more documentation, just make it a scheduled thing, part of the culture. Finally, the principle of least privilege, which is, according to Wikipedia, giving a user account only those privileges that are essential to that user's work. And in the world of Autopkg, that usually applies when you're setting up things that plug into Autopkg. So for example, the JSS API account that you're going to use to import into JSS importer, when setting up monkey repos, setting up access, get access to the monkey repo or any other repository, SSH access, Amazon Web Services, email, all things that you should limit to only what's essential. And don't use your regular company email address in Autopkg, for example. Just use one that's specific to notifications. So, what does it all mean? You're probably thinking, but Elliot, most of these preventative steps take time. The point of Autopkg is to save me time, so why should I spend time babysitting it after it's already saved me that time? What's the point? I would say that the point of automation is not to minimize or eliminate the time spent, but rather to maximize efficiency and reliability. And if you maximize reliability and efficiency, it's like a virtuous circle. It just keeps going. So when you save automation, when you save time with automation, I try to think about paying back about 20 to 40% of that time towards future automation, future learning, future reliability improvements. And all the things that I mentioned are ways that you can do that. Now, I hope some of you recognize your avatars here. My favoriteest thing about Autopkg is not anything that comes in the package installer. It's actually everybody who's sitting in the room here and everybody who's out on GitHub and on Slack and Twitter collaborating every single day. So I'd say one of the best things you can do, the best things you can spend like 20 to 40% of your time that you've saved with Autopkg on is contributing back to the community, going out and learning new things for yourself, asking questions for yourself, answering questions once you've got the answers that you wanted, spreading that knowledge to other people. That's really what keeps it going. And really, when you're well connected, you're going to have fewer problems. You're going to catch them sooner. You're going to reinvent fewer wheels, and everything's going to be better with life and rainbows and unicorns, right? So obviously, by attending conferences like this, you're on the right track. So I congratulate everybody here. And let's all keep learning together how not to do bad things.